Okay, yesterday we got cut off on our last example, so let's go ahead and go through this one. This bottom one, we have two polyatomic ions. We've got one right here and one right here. So if you look on the front of your packet, you'll notice the first one is ammonium. It's NH4 with a positive charge. And then the SO4, this is sulfate with a 2 negative charge. Okay, once you have those written out into their ions, now we're going to balance. So right here, we have two nitrogens. Here we have one, so we're going to put a 2 in the front. So when you balance, you're doing the same thing as we've done before. You're just using coefficients. And then notice here, 2 times 4 is 8. 2 times 4 is 8, so you have 8 hydrogens. 1 sulfur, 4 oxygens, 4 oxygens. So now this is balanced. And then you're going to count how many ions you have, moles of ions, by the coefficients. So you've got 2 here, and you've got 1 there, which equals a total of 3 moles of ions. All right, let's go ahead and do some more. Okay, these are just examples of what we just did. So practice doing these on your own, and then pause the video and then come back and look at what we've done. So this first one is beryllium iodide. So if you look at your periodic table, you're going to break this apart because beryllium is a metal, iodine is a nonmetal, so this is going to be an ionic bond that breaks apart. Beryllium is in group 2, so it has a +2 charge. Iodine is in group 17, so it has a -1 charge. And now we're going to balance it. So right here you've got 1 beryllium, 2 iodines, only 1 here, so you're going to put a 2 in the front. Okay, now, so that means we have a total of 1 plus 2, we have a total of 3 moles of ions. Now in this one, when I was teaching it in class, students were getting really confused, and some of them were putting iodine as I2. I2 is when it's in its molecular form. So when we talk about diatomic or Brinkelhoffs, right here when we're breaking it down into its ion. And so it's no longer in its molecular form. So all we want to look at is the charge, and then we balance using coefficients. So be aware of that when you're doing these. Okay, we're breaking it down into an ion, not a molecule. Okay, the next one is C3H6. This is called propene. Go ahead and pause the video and do this one. If you need help, look at page 3 on the chart that we just did yesterday. Okay, coming back, if you notice on this one, carbon's a nonmetal, hydrogen's a nonmetal. They're not polar, these are non-polar covalent, so that means this is just going to stay together in its molecular form. It's not going to break apart, which means we have 0 ions because you don't see any charges on this at all because it's just staying together. Okay, the next one is aluminum sulfate. So if you look at this one, aluminum's a metal. It's in group 13, so it's going to have a 3 positive charge. Whenever you see multiple elements or multiple atoms, look on your polyatomic ion sheet. So in this case, this is sulfate, SO4 with a 2 negative charge. Now that that's broken apart, and we know it can break apart because this is an ionic compound. This is a metal plus a non-metal. Okay, now we're going to go ahead and balance. So right here, we've got 2 aluminums. Here we only have 1, so we're going to put a 2 in the front. Here we've got 3 sulfurs, only 1 there, so put a 3 in the front. 4 times 3 is 12, 3 times 4 is 12, so this is now balanced. And then look at your moles, add them up. 2 on the aluminum, 3 on the sulfate, for a total of 5 moles of ions. Okay, if you have questions on that, please make sure you come in and get some help. The rest of today, we're just going to manipulate equations. We're also going to do this next week on Monday. But I just want to make sure you're okay on this. So it might be a review. It might be kind of new. So go ahead and pause the video, rearrange to solve for the equation, and then check your answer. And then I will go through if you want to come back and unpause the video. So on this one, we're rearranging the equation to solve for B. Whenever you have a fraction, you got to get rid of the denominator. And you're always going to do opposite of what it's saying. So this is showing division. So we're going to multiply C on both sides. Okay, so now we have B equals C times X. And that's what we're solving for is B. So there's your answer right there. Okay, the next one, we're using the same equation, but this time we're solving for C. So again, And this is the thing that throws students off the most, is when the denominator, you have a denominator. So get rid of that first. So you're going to go ahead and multiply by c on both sides. So now we have cx equals b. So to get c all by itself, you're going to do the opposite of what it's doing. It's multiplying, so we're going to divide because it's opposite. So you're going to go ahead and divide by x on both sides. So now you have c equals b divided by x as your rearranged equation. Okay. And there are your answers if you're doing this at home. Okay, let's do this one. Rearrange to solve for b. You guys, we already did this one, but we're going to plug in numbers in just a second. So again, solving for b, you're going to multiply c on both sides. So you have cx equals b. And the next question we're going to do is we're going to apply that and plug in numbers. So we just found that b is equal to x times c. Here's our numbers down here. We're just going to plug that in. So b is going to equal 28 for x. Multiply that by c, which is 7, which is going to give you 196 is your answer. So b equals 196. Okay, we will do more of these on Monday. So if you have any questions on what we've done, please let me know. Have a great weekend.